Hello everyone, welcome to C Programming and Data Structures. In this presentation, we will see this program that is stack ARR 0 as the top. This is part 1 of stack ARR 0 as the top. So without any further delay, let's get started. This is the initial state of stack ARR. Okay, assume that this is the initial state of this stack ARR. This is nothing but an array which is representing a stack. That's why I've named it stack ARR, right? This is the current state of the stack. Now, currently stack ARR has 4 elements. You can clearly see this, that this stack ARR array has 4 elements. This means that our stack has 4 elements. And according to our previous implementation, the topmost element of stack is 5. Isn't that so? This is the topmost element of the stack, right? The newly inserted element must be the topmost element of the stack. And here obviously the topmost element changes with time. Here you can see this is the topmost element. If we try to add a new element, the new element will be inserted in this position and then this becomes the topmost element, right? Currently you can see that top variable is holding this value 3. Obviously this indicates that the topmost element is at index 3. You can clearly see this, that this is the topmost element of the stack, right? This means variable top has a value that indicates the index of the last inserted element or the topmost element of the stack. Obviously, this top variable is holding value 3, which is the index of the last inserted element or the topmost element of the stack, right? There is no doubt about this. If you haven't watched our previous lectures, then I would recommend to watch the lectures first. Then only you would be able to understand why this element is considered as the topmost element of the stack. Okay? Now let's try to insert a new element inside stack. Now we are actually interested in inserting a new element inside this stack. Obviously in this array, this is the representation of the stack only, right? Let's try to insert a new element inside stack. For this purpose, we will call push function. And this is how our push function looks like, right? Here first we are checking if top is equal to max minus 1, which means that if the array is full, then we will print this message stack overflow, right? Otherwise, we'll simply increment the top by 1 and we will store data inside stack ARR top. As simple as that. Now we will try to increment the value of top by 1, right? Obviously, because top is not equal to max minus 1. We'll first increment the top by 1. You already know what this max is, okay? I'm assuming that you already know what is the max variable. It is important to watch the previous lectures before moving on to this lecture. Okay. So let's just first increment the top variable by 1. Here it will become 4. And after this, we will call stack ARR top. And here in this position, we will store our data. Okay. The data which we have received. Fine. Let us assume that data holds this value 43. And we want to insert this value at this position because top is 4, which means that this is going to be our topmost element, right? So here we will store this value 43 and this is how our stack looks like, right? And obviously you can see top is 4, which means that this is the topmost element of the stack. This is how our push function works, right? Now, in this presentation, we want to write a program to implement a stack in an array stack ARR using stack ARR 0 as the top element. That's what we want to do in this presentation. We want to implement a stack in an array stack ARR. And here we want that stack ARR 0 must be the topmost element of the stack. Fine. We want that the first element of the array must be the topmost element of the stack. So this is entirely a new program, okay? It seems easy, but it is not that easy. But after completing this lecture, you would be able to understand how to write such a program, okay? Here is our stack ARR. This is the initial state of stack ARR. You can see that stack is currently empty. We want stack ARR 0 to be our new top. Fine. Do we need a variable named top to keep track of the topmost element? Is there any requirement of keeping a variable top for the purpose of storing the index of the topmost element? Think about it. Stack ARR 0 will be our new top and it will not going to change. Isn't that so? This is fixed. This position is fixed. Our new topmost element will always be placed inside this position. Isn't that so? Therefore, in my opinion, there is no need to keep a top variable because we already know the index of the topmost element. It will always be this value 0. There is no need to keep track of the last inserted element, but we have to keep track of the first inserted element. Isn't that so? We always have to keep track of the first element instead. This is a completely different story. In the previous presentations, we have seen that why we are keeping the track of the topmost element, because the position of the topmost element always changes with time. Isn't that so? But here we have to keep track of the first element instead. Okay, there is no need to keep track of the last inserted element because last inserted element position will remain same. I hope this idea is clear to you. Here I am considering a simple example to demonstrate why top variable is not required at all and why we have to keep track of the first inserted element. Here I am using these sequence of steps: push 1, push 2, push 3. This means that we want to insert this element first, and then this element, and then this element. Let's just call push 1, which means we are interested in calling the push function, and to the push function we are passing 1. Okay. Here is how the stack ARR looks like after inserting this element. Isn't that so? 1 will be our topmost element. After this, we are interested in calling push 2. Let me tell you, this is not the push function we were talking about previously. This is the new push function, which will push the topmost element at this index. Okay. This is very important for us to understand. This is not the previous push function. This is the new push function. We will actually define this function later. Right now you must understand the logic behind this push function. What this push function does. Here after pushing the element 1, we are interested in pushing the element 2. Okay. Now before pushing this element 2, we have to create the room for this element. Here we have to make this space empty. For this purpose, of course, we have to shift this element towards right. Isn't that so? It is important to push 2 at index 0 because this is going to be our new topmost element, right? In order to do this, first we have to shift 1 towards right. It is important to shift this element towards right first, and then we can add 2 at 0th position. Fine. So let's just shift this element towards right, and then we can easily insert this element at this position. Obviously, we must not replace 1 by 2, right? Here we first have to shift 1 towards right, and then we can insert element 2 at this position, right? This is very simple. After this, we are interested in pushing this element. Again, we have to follow the same procedure. First, we have to shift this element towards right, and then we also have to shift this element towards right. Isn't that so? Obviously, we have to create room here and not here. So here, you can see this space is empty. Therefore, we can insert this element at this position. Fine. I hope this idea is clear to you. You can see this is the topmost element of the stack, right? And there is no need to keep track of the topmost element. Isn't that so? It is a good idea to keep track of the first inserted element, and it is also clear that there is no need to keep track of the last inserted element. The position of the last inserted element is fixed. You can see the position of the last inserted element is fixed, but the position of the first inserted element is changing. Therefore, we have to keep track of the first inserted element and not the last inserted element. I hope this idea is clear to you that we always have to keep track of the element whose position is changing with time. Here you can see that the position of the first inserted element is changing with time. That is why we have to keep track of the first inserted element. But here you can see that there is no need to keep track of the last inserted element as the position of the last inserted element is fixed. Correct? We have to consider two different things. First, we have to keep track of the first inserted element, and obviously we must shift all elements one step towards right and push the new element at index 0. Isn't that so? Let's just try to write the code for keeping track of the first inserted element. For this purpose, of course, we have to declare this global variable first, and we must store -1 initially to indicate that the stack is empty, right? This is the global declaration of the variable first. Instead of keeping a top variable, we will keep this variable first, which actually stores the index of the first inserted element. Fine. This is done. You can see that currently first is holding this index 2, which means that the first inserted element is at index 2. You can see this, right? After this, we have to shift all elements one step towards right and push the new element at index 0. We have to write the code for shifting all elements one step towards right? And push the new element at index 0. Let's say we want to push this element 30 in the empty stack, not in this stack, okay? For this purpose, we will use this push function. Here I will explain each and every step. This push function will receive the data, and we know data is 30. After this, we have this I variable. I have declared this variable for the purpose of iteration. So this is an iterator. After this, I am incrementing the value of first by 1. First plus equal to 1 means first equal to first plus 1. We know that first is a global variable and currently first is holding -1 because we are talking about a stack which is empty. Therefore, first variable must hold -1. But after this step, -1 will get replaced by 0. And then after this, we have this for loop. And in this for loop, you can see first I is initialized by first, right? So here we will store this value inside I. And then we will check this condition, is I greater than 0? You can see this that I is not greater than 0. Therefore, we will get outside of this for loop and we will land at this particular line of code. Stack ARR0 equals to data. Now what does it mean? Here you can see this is stack ARR and currently you can see that at this position 30 is stored, right? Now I think the idea is clear that this for loop is used for the purpose of shifting the elements towards right. And then you can see after this, we can insert our data at this position. Now, we are interested in pushing this element 90. Now we will try to push this element. First, obviously this push function will receive this value. And then we must have to declare our I variable. After this, we have to increment the first by 1. This will get replaced by 1. And then we have this for loop. Here first I is initialized by first. And then we must check this condition, is I greater than 0? Yes, you can see that I is greater than 0. Therefore, we will get inside this for loop. And here I have put this line of code, stack ARR I equal to stack ARR I minus 1. This is very simple to understand. Here obviously this I will get replaced by 1 and I minus 1 will get replaced by 0. What does it mean? Why I am putting this line of code? Here I want to shift this element towards right, and shifting means just copy and paste this element in this position. That's it. Stack ARR1 must hold the value of stack ARR0. Stack ARR1 must hold the value of stack ARR0, right? So here first we know that I will get replaced by 1 and I minus 1 will get replaced by 0. Here you can see this is the line of code so obtained, that is stack ARR1 equal to stack ARR0. So after this line of code, this value will get shifted towards right, and shifting means copy and paste this value at this position. That's it. After this, of course, I must be decremented by 1. Here I becomes 0. And then after this, we are checking this condition. Is I greater than 0? Obviously not. I is equal to 0. I is not greater than 0. We'll get outside of this for loop and we will land at this point, right? Here we will simply store the data at this position. That's why I've told you shifting means just copy and paste, because eventually this value will get replaced by our data, right? You can see that data is holding this value 90, therefore this will get replaced by 90. That's it. This is how our stack ARR looks like, and this is the logic of push function. I hope this is clear to you. Now we will see the complete code in code blocks. Here is the complete code of the push function. We have hash include stdio.h, hash include stdlive.h. Then we have this hash define max 5. I only want to insert 5 elements in my stack. That's why max must be 5. Here we have int stack ARR max, and then we have int first equal to -1. Here you can see we have this push function, right? And then we have this print function for the purpose of printing the elements on the stack. You can see this on your own, how this actually works, right? Here obviously this for loop is required because the traversal is required for the purpose of printing all the elements of the stack, right? That is why I've used this for loop. After this we have this main function, and in this main function I'm calling the push function thrice. First I want to insert this element, then this element, and then this element. Fine. and then I'm calling print function for the purpose of printing all the elements on the screen. Let me just execute this code. You can see that these are the elements printed on the screen, 40, 90 and 30. Obviously 40 is the topmost element, then we have this element and then this element. This is the topmost element of the stack because this is the last inserted element of the stack, right? So our code is working fine. Okay, let me just remove this and let's just execute this code. You can see the status of the stack 90 and 30. Last inserted element is 90, that is why this is the topmost element of the stack. And then after this we have 30. You can see in this print function we have for loop which runs from 0 to first. First variable always keeps track of the first inserted element, right? Here stack ARR 0 will get printed first and then stack ARR 1. This is stack ARR 0 and this is stack ARR 1, right? I hope this idea is clear to you. Okay friends, this is it for now. Thank you for watching this presentation.